we're going to be completing the square today, which you're probably like, Miss Long, what does completing the square have anything to do with circles? Well, I'm going to tell you how they relate in a moment. Guys, so completing the square, you probably learned about this in a previous math class, but completing the square is actually another way to find zeros or roots or x-intercepts, which the only way we've talked about how to do this is by factoring or the quadratic formula. Well, guess what, you guys? Like we talked about before, the quadratic formula works every single time when you're trying to find zeros or roots or x-intercepts or solutions. Those all mean the same thing. Okay, so completing the square is also another way that you can find zeros, roots, or x-intercepts no matter what. Okay, it always works, which is pretty exciting. But you're still probably like, Miss Long, why are we solving quadratics when we're doing circles? Like, that makes no sense. Well, you guys, sometimes our pretty standard form of a circle equation is not in standard form, okay, which is a problem. And we want to get into standard form because standard form tells us all those nifty things about the center and the radius. So just to kind of do a quick recap, on paper, sorry. Here it is. All right, so eventually we're going to get to problems that look like this, and we're going to want to write these problems into this pretty standard form. Okay, which if you notice, these don't look anything like the standard form we've been working in. But guess what, you guys? Completing the square is going to help us to get these not so pretty equations. I mean, they're pretty. I'm not just going to say they're ugly or anything. They're pretty equations, but they're not going to help us to find the center and the radius, which we want to find those things because it's helpful when we're dealing with circles. So we're going to be completing the square not only just one time, but actually 2 times to get this form of a circle, so non-standard form, into the pretty standard form. But anyways, before we can do that, we need to recap how we complete the square, because it's probably been a while since you've done it, or maybe you've never done it. I don't know. But anyways, when we complete the square, we're actually not going to be doing it to its full potential. Usually when you complete the square, you end up by finding like x equals a number. Okay, we're not going to do that. We're just going to get it to kind of look like this form right here. And we're actually going to get it to look like just the x part. So we kind of want our form to look like x minus something squared equals a number. That's our goal, because eventually we're going to have x minus a number squared plus y minus a number squared equals a number. So we're kind of building up to this form. So we're going to take it one step at a time. So we're just trying to get our equation to look like this first before we can tackle problems that make it look like this. So we're kind of doing baby steps right now. Alright, so completing the square. So whenever we complete the square, our goal is to get all the variables on one side of the equation and all the constants or numbers without variables onto the other side of our equation. Okay, so that is our end goal. So our end goal is on this side of the equation, we want variables. So in this case, we want all the x's on this side. Okay, and then on this side, we want all the constants or numbers without x. So no x's or numbers without x, however you want to phrase it. So that's our goal. So I'm going to be rearranging this equation to get all the x's onto one side and all the numbers without x or constants onto the other side. Because the x's, first of all, are besties, right? They want to be together, okay? And then the numbers without x's want to be together because they're besties. So that's our goal. Guys, so currently I have this negative x on this side, which is irking me because it's not a constant. I want to move all my x's over here. And this negative 9 right here is irking me because it's a constant, which means it needs to join this side. So I'm going to be moving negative x to this side of the equation and negative 9 to this side of the equation. So my x's can be together and my things without x's or my constants will be together. They don't get along, so we're just going to go ahead and separate them for a little bit so they can kind of figure out their life and hopefully one day get along. Alright, so I'm going to rewrite this equation since I just kind of wrote all the stuff under it so I can start working with it. Get my papers together. Sorry, guys. Alright, so I'm going to write x squared plus 9x minus 9 equals negative x plus 2. Okay, so first I'm going to move my x over to this side so it can be on the side with the variables. So how do I move negative x to the other side? Oh man, you guys are totally smart. You do add x on both sides. Okay, now before I can add it on this side, I have to think what makes sense to add an x to. Would it make sense to add x to x squared, to 9x, or to negative 9? Which one of these terms is a like term to x? Oh my goodness, you guys are so smart. It is the 9x. So the one that is the like term with the x is the 9x. So I'm going to add this bad boy to 9x. Guys, which secretly there are 1s in front of these x's, if that helps you. Guys, so negative 1x plus 1x cancels and turns to 0. Bam. And 9x plus 1x is 10x. Okay, so now I have x squared plus 9, or not 9, sorry guys, x squared plus 10x minus 9 equals 2. Alright guys, we're getting closer to be able to complete the square. But before I can complete the square, I need to move all my constants to the other side. So I need to add, or I need to move that negative 9 to the other side. So how do I move a negative 9 to the other side of my equation? Good golly, Miss Molly, you do add 9 on both sides. Oh man. So negative 9 plus 9 cancels and turns to 0. And 2 plus 9 is 11. So now I have x squared plus 10x equals 11. Alright, so now that I do have the variables on one side and my constant on the other, now I can complete the square. Okay, so the way that we complete the square, what that phrase means is we're going to do something to make this a perfect square trinomial. So what that means is that we're going to make a trinomial, which if you remember, a trinomial has 3 terms. Okay, so we're going to make this bad boy have 3 terms, and it's going to be something called a perfect square, which it'll make more sense why it's a perfect square in a little bit. We're basically going to make this thing into a binomial square. So it's a perfect square trinomial because when we factor it, we'll have 2 of the same factors, which makes it a perfect square. But we'll talk about that in a little bit. Okay, so we're going to force this thing to be a perfect square trinomial, whether or not it wants to be. We're going to kind of be mean. We're going to let the demon cats get us a little bit and make it be a perfect square trinomial, whether or not it wants to be. So it doesn't really matter how it feels right now. We're going to make it whether or not it wants to be. All right, so the way that we complete the square, so this is when we're completing the square. Okay, the way that we make this bad boy a perfect square trinomial is by doing this nifty thing right here. B over 2 squared. Guys, when I'm referring to b, I'm talking about when we're in our standard form of a quadratic, which is ax squared plus bx plus c. So the b, you guys, is the number in front of the term that contains just x, not x squared. So which number is in front of the x? It is the 10. Okay, so guys, our b value is 10. Okay, so we're going to be doing 10 over 2 squared, and that's going to force this bad boy to become something called a perfect square trinomial, which is pretty insane if you ask me. All right, so b over 2 squared, we're going to do 10 over 2 squared. Sorry, that's a 10. I know it's looking a little rough. So 10 divided by 2 is 5, and 5 squared is 25. Guys, so we're going to add this onto the side, but if you ever add one thing to one side of an equation, we're going to add it to the other. So what I'm going to do, you guys, I'm running out of space, so I'm going to bring this up here. Okay, so basically, I want to end up with 3 terms. Guys, we're going to add our b over 2 squared on the one side of our equation, but if we add it on the one side, we have to add it onto the other side. So I'm going to be adding the same number on both sides of my equation to keep this thing balanced. So I'm not changing the equation if I add the same thing onto both sides. Oh, sorry guys. I'm trying to make you see the whole thing, but it's not working. Okay. Guys, so this b over 2 squared is what I'm going to insert into my equation in both of these nifty spots right here. So this 25 right here is going in the box. This is the box. Okay, so I'm going to add 25 on both sides. Now you don't have to put 25 in the box. It just, for me, it helps the visual to see that we're adding the same thing on both sides. All right, so this is coming from that b over 2 squared. b over 2 squared. That's where that number is coming from. b over 2 squared. Okay? That says b over 2 squared. I know my handwriting's struggling today. Sorry, guys. Okay, so now I'm going to combine my like terms before I start factoring this bad boy. Okay, so we're going to have x squared plus 10x plus 25 equals 11 plus 25. That will give me 36. Guys, so the final step that we're going to be doing to complete the square is to factor this bad boy, which when we have 3 terms, how do we factor? Jiminy Cricket, you guys are so talented. You do either do slide and divide or general factoring, or you could do the quadratic formula. But I'm just going to do slide and divide because for me it's a little faster and I want to be efficient right now. Guys, so I'm going to take this and I'm going to slide and divide with this bad boy. Slide and divide. Okay, so I want to slide my a to my c, which if I don't see a number in front of my x squared, what is secretly in front of it? Yes, it is. It is a 1. Okay, so we slide our a to our c, so we're sliding a to c, or multiplying a times c, that's all that means. So 1 times 25 is 25, so I want to find 2 numbers that both multiply to equal 25, which is AC, and add to equal B, which what is my B? It is the 10. You guys are on a roll today. Guys, now, the reason why this is called a perfect square trinomial is because what we're going to be able to do is write this as a binomial squared. Now, what's a binomial? Yes, it is. A binomial is 2 terms. So we're going to be able to write this, instead of having 2 separate parentheses as our final answer, we're going to have the same parentheses repeat, so we'll be able to write it as a binomial quantity squared. Okay, so basically the perfect square will make this thing a perfect little square, which we can write it as a binomial square. That's all that a perfect square trinomial means. Okay, so basically, you guys, when we get done, if we do it right, these 2 numbers, well, these 2 numbers have to be the same as these 2 because we need to find the same numbers that multiply to be 25 and add to be 10. But if we do it right, these 2 values should be the exact same number, and these 2 values should be the exact same number. So let's see if we can come up with 2 the same exact number that will both multiply to be 25 and add to be 10. So what times what gives you 25, and what plus what gives you 10? Oh man, it is 5. So do you guys see how these numbers are the exact same? Okay, when you complete the square, that should happen every single time. You should end up with the same 2 numbers when you're doing this process. If you don't, you might need to reevaluate the problem, possibly your life. I don't know, that's on you. Okay, so technically when we write our final answer, when we do our slide and divide, remember we do x, we do our 2 parentheses with x's. Since these are both positive 5, I'm going to put them as plus 5. And at the very end, we slide and divide. We divide by a, which in this case, a is 1. Which 5 over 1 is just 5. So this is like x plus 5 times x plus 5. Which, since this repeats, technically I could write this bad boy as x plus 5 quantity squared. Whoa. Okay, so if we have a perfect square binomial, this should happen every single time. We should end up with 2 of the same exact factors, which means we'll have a binomial square. Okay, when you're completing the square, it forces you to do this. This magic b over 2 squared makes the equation do that, which is pretty cool. Okay, so we have x plus 5. I'm going to bring this bad boy down, equals 36. And guess what, you guys? That's all we're going to do when we complete the square for circles. Okay, if you normally complete the square, you'd want to actually solve for x and find your zeros. Okay, but we're not trying to find zeros. We're just trying to focus on getting our equation to look like the equation of a circle, which if you guys remember, this is kind of looking like that x minus h squared thing. Okay, so we're trying to mimic this equation. So this is as far as we're going to go. Okay, if I ask you to find the zeros or roots or x-intercepts, you want to actually solve for x. But we're not doing that right now. So guess what, you guys? This problem is donezo. And since that was so much fun, you guys get a lovely cat because cats just make everything better. Quite cat-tastic, you guys.